you have 1 second. I will just I forgot to record it. Okay, here we have the supervised learning. We discussed about what is supervised machine learning. In the case of supervised machine learning, you need to have this set of input features and the dependent variable. Supervised machine learning. In the supervised machine learning, you have something called regression. And then you have something else called classification. Here you have binary classification problem. And you have here you have multi-class, and then multi-label classification problem. Okay, so binary classification problem, we'll start with understand this one. Since the classification problem is also falls under supervised machine learning, we need to have the combination of input features and the dependent variable. Okay, the dependent variable is called label in the case of classification. For example, in the case of binary classification problem, let's take some data set. Okay, you have some transaction number and then the transaction date, and you have the amount debited, and amount credited, and then is fraudulent. Okay, you have a column by the name of is fraudulent. So all these features are called your input features. These are called your input features. These are called your input features. Okay, and this is your labeled output variable. Okay, labeled output variable is fraudulent. Okay, want to predict the categorical response value or output variable, which is nothing but is fraudulent, based on the set of these features. For example, the transaction number is 101, some date, okay, amount debited is or credited, or but debited is, let's something like this. And is it fraudulent? If it is in the past, yes, this is the fraudulent transaction. And so there's some historical data, right? So and so pattern you find it, that is your fraudulent transaction. So and so in pattern you find it, that is your no fraudulent, right? No fraudulent. So here the is fraudulent is a binary categorical outcome variable. In this column you will find either yes or no and all. Okay, so here we take all the input features, and along with the labeled feature, we are going to train the model. And once you train your model, when you same as your linear regression model, okay, once you train your model with this set of input features and the labeled output feature, you apply the trained model on the unseen data, which is nothing but the test data. Okay, so once you apply the model on the test data, your model is supposed to predict the target outcome variable as yes or no only, not the value. So in the case of regression problem, we have predicted the outcome variable, numerical outcome variable, right? We predicted the numerical outcome variable. Whereas in this case, we are predicting the binary outcome variable, or binary class. So if my test data set is something like this, transaction or transaction date, amount debited or credited, the test data, okay. If I train model, if I apply the model on in this test data, the model should predict yes whether this transaction fraudulent transaction or yes or no. It has to give me the label yes or no. Okay, that is what it has to predict, and give me the output as yes or no. Okay, that is what we do it, and that is what we do it with the help of the classification problem. Importantly, in the case of binary classification problem, the class labels are yes or no in this example. Okay, the yes can be 1, the yes is 1, and no is 0. Okay, the yes is 1 or no is 0. So if instead of yes or no, in some cases they will give you 1 here. Okay, 1, 0. 1 means true. What is true? What we are intent to predict whether the given transaction is fraudulent or not. That is what we intend to predict. So here the S is nothing but 1, right? 1. So here no is 0. Okay, yeah, N is 0 and Y is 1. Okay, is fraudulent 1. Okay, no. So either Y or N, or instead of S you can put 1, N is 0. Correct? So same way, in the similar to the linear regression model, we need input and output variable. We need the input features and then output variable, right? Output variable. So with the help of the input features, we are going to with this, let's assume that this is the historical data. Yeah, you have input features and the label output features given by your manager. You take this data, you have the input features as well as the labeled output feature. Okay, instead of saying dependent variable, I call this a label output feature because we are talking about classification problem. So in this case, let's say your manager given you the set of these two things, okay, input features and label. You are going to train your model. And once you train your model, what is the next step you need to do? Step 1, train your model with the historical data, which consists of input features and labeled output features. What is the next step? Step 2, what we are going to do? Guys, joining on time, regular, it is not helpful. Okay, tell me what is the step 2, what we are going to. Now I train my model. What is the next step? So even if you cannot join, that's okay. But are you good with logically? Are you thinking? Are you able to understand or not? Look here, this is what the script which we discussed, right? One second, it is being open. What happened here? It takes a lot of time. This is regression problem. That's okay. And here, what did we do? We trained the model, right? We trained the model. And then what we are supposed, what is the next step? Once you train the model, what is the next step we need to do? What is the next step here? What is the next step? Yes, you are correct. Who is correct? Soumya is correct. And Praveen, you are correct. Sara, you are correct. Jamal, you are correct. And Deepa, you are correct. How about others? How about the others? Step 1, train your model. To train your model, you need to split the given data into training and test data. Fine. High level, I'm asking high level steps. Step 1, you need to train your model. Once you train your model, என்ன பண்ணுவீங்க அடுத்து? மிலிட்டரிக்கு ஆளை எடுத்து ட்ரெயின் பண்றோம் எப்படி ஷூட் பண்றதுன்னு. அப்புறம் என்ன பண்ணுவோம்? கவர்மெண்ட் அவனுக்கு சாப்பாடு போட்டு வச்சுக்குமா? டெஸ்ட் பண்ணுவோமா இல்லையா? Whether he is shooting well or not, right? So next one is we are applying the model on the unseen data. Guys, கஷ்டம்ப்பா. இப்படி இருந்தீங்கன்னா ரொம்ப கஷ்டம். மேனேஜர் ஒரு மாசத்துல பேக் பண்ணி அனுப்பிச்சு விட்டுருவோம், போயிட்டு வாங்கிட்டு. Okay, see what I'm saying, right? Step 1, you train the model, and step 2, you apply the trained model on the unseen data, right? So guys, the others, please don't get me wrong, okay? And again, it is not my intention to put you guys down, right? Please concentrate here, okay? And while you join the session, if you watch mobile and WhatsApp, and if you talk to your friends, ஒன்னும் கடவுள் கூட ஹெல்ப் பண்ண மாட்டார். இங்க வந்து linear regression model we train, and similarly the same step தான், train the model and then test the model. How do we test the model? We apply the train model on the test data set. ஏதியாவது வச்சுக்கோங்கப்பா. ஜீவானந்தம் வேற யார் இருக்காங்க? ஃபாத்திமா அண்ட் வேற யாரு? ஜெயஸ்ரீ, அவ்வளவுதானா? அவ்வளவுதான். So this is the one, right? So train the model and apply the train model on the unseen data to make a prediction. In the case என்ன பண்ணா logistic regression, the same step, but in this case we are going to apply the model on the same unseen data, but here the model has to predict either yes or no. Instead of numbers, it has to give y or no, or it has to give either 1 or 0. 1 means true, 0 means false. Okay, that's all. It's that much simple. Okay, fine. So next one is okay. Here I discussed about now we discuss about to solve the classification problem. We use different types of classification problems. One is binary classification problem, multi-class classification, and multi-label classification problem. In the case of binary classification problem, we are going to predict the target value as either 1 or 0, right? Whether it is true or false, yes or no. Okay. Multi-class classification. What is multi-class classification problem? Supposing you are given bunch of fruit images: apple, orange, and avocado, and pomegranate, and you train the model with the data set, historical data. If so-and-so image is called pomegranate, so-and-so image is called your dragon fruit or pomegranate, and so on. Now, if I give you some image and if I ask you, hey, can you show this image to your model and tell me what this fruit is all about? Okay. And your model has to give me either it is apple, or it has to say it's avocado, or it is a dragon fruit, right? So in that case, so many fruits are there. It has to predict, it has to assign the label based on the type of the product. Hence, that is called multi-class. You have more than 2 classes are in that case. But there are cases you will have only 2 classes. One is yes or no, otherwise a true or false. Okay, that is for binary classification problem. Next one is multi-label problem. What is multi-label classification? Multi-label classification problem. Multi-label classification problem is we are assigning more than one label itself. See, so far we discussed about only one dependent variable, right? Whether it is a binary classification problem or multi-class classification problem, the target outcome variable will be just label, only one labeled output variable. See, in the case of classification problem, I'm using the term label. Please remember this: input features plus label. Okay. And in the case of multi-label classification problem, for example, you have a movie name. You have a movie name, and here Harry met Sally. For example, you have a movie Harry met Sally, right? Harry met, and here a single movie can have more than one flavor, right? So this movie is comedy movie as well as it is a romance movie, comedy and romance. Okay, so we cannot say this movie is fully comedy movie. It is a combination of romance as well as comedy. Okay, hence in this case you need to have more than one level, unlike the multi-class and binary classification problem. In the case of multi-label classification problem, you need to have more than one label. Okay. Now what we will do is we'll start with understanding the binary classification problem. Most of the time we work in the real-time scenario, the binary classification problem and then multi-class classification problem. But before we jump in, let us understand the probability and odds. And what is probability and odds? Let us understand. That is central to understanding the logistic regression. Using logistic regression, we will take a look at how we can solve the classification problem, binary classification problem. And the logistic regression problem is within the logistic, there are two types. One is, if you want to predict the target outcome variable, which is of binary, that is your binary logistic regression model or logistic regression model. And if you want to predict multi-class, if you want to assign, or if you want the model to predict the class label for multi-class classification problem, that is, you have some multinomial logistic regression. Okay, so you have different types of logistic regression is there, but most of the time you'll be working with binary classification problem. Okay, to understand the binary classification problem, logistic regression, let us first understand what is probability. Okay, first let us understand what is probability. What is probability? All of you, please type it in the chat. What is probability? Yes, Swami, you're correct, right? So number of favorable outcomes divided by total number of possible outcomes. Total number of favorable outcomes, number of favorable outcomes divided by total number of possible outcomes. Supposing when I toss a coin, if I ask you a question, like, if I let you know I'm tossing a coin, and what is the probability of getting head? So what is your answer? What is the probability of getting head? Head or tail? What is the probability of getting head, or what is the probability of getting tail? 1% drop. If I ask question, 1% dropped. Very basic question in statistics. Number of favorable outcomes divided by total number of possible outcomes. Jivanandam, what is this here? If I toss a coin once, what is the probability of getting head? Statistics student. Others are non-statistics. Yes, Soumya, Anwar. Yeah, Praveen, you are correct, right? How about statistics students? To getting the head, right? So what is the total possible outcomes? You can get either head or tail, right? Out of head or tail, what is the probability of? So my question was, what is the probability of getting head? Right, 1. 1 divided by 2 is 0.5. There is a 0.5 probability of getting head, and there is a 0.5 probability of getting tail. Correct? School time also we studied. Okay. And also remember that the probability value is always between 0 and 1. Okay, 0 and 1. And this is one rule you need to remember this. Okay, what is probability? Probability is nothing but number of favorable outcomes divided by total number of possible outcomes. And and the rule for probability is always between 0 and 1. The second rule is the sum of probabilities of all possible outcomes is 1. So if you add these two things, right, the probability of getting head is 0.5, the probability of getting tail is remaining 0.5. If you add these two things, you'll get 1, right? It should not go beyond 1. Okay, that is what the second point tells. Sum of the probability of all the possible outcomes. Here, all the possible 0.5 and 0.5, 1. It should not exceed 1. The probability value always lies between 0 and 1. You understood? This is what I'm trying to say. Next one is odds. What is odds? What is odds ratio? How many of you remember it? What is odds? What is odds and odds ratio? Can someone tell me what is odds and odds ratio? Jivanandam, statistics படிச்சீங்களா இல்லையாப்பா? Odds of theta. For example, here the probability of an event occurring not occurring. Probability of an event occurring and divided by probability of an event not occurring. That is what called odds, right? And here I'm going to write probability of success. We can rewrite it something else. Probability of numerator, okay? And what is the denominator? Tell me here. Let me see how many of you are dropping again. So odds, what is odds? Probability of an event occurring divided by probability of an event not occurring. So the probability of event, so I put it here in the numerator, right? Probability of success. The denominator now. What will come in this? This is a basic thing here in statistics. Yeah. So why so much of late? Probability of success divided by denominator, what will happen? So one is probability. If you subtract the success from the 1, the rest of the thing is your failure, right? You subtract the probability of success from your the total probability is 1, right? So if you subtract this one, you will get the the probability of event not occurring, will get it. Okay, so and remember that the probability values ranges between 0 to 1, the probability, right? Probability values. And what about the odds? The values of odds ranges from, between which values? Odds ranges between which values? Just give me a second. I got some call. In the meanwhile, you just type it in the chat window. What is this thing? What value? The odds ranges between which value? What value, ma? Statistics. So probability values ranges between 0 and 1, right? Probability ranges between 0 to 1. இது எல்லாமே ப்ரீவியஸ் வீடியோல பேசியிருக்கேன். நீ யாருமே பார்க்க மாட்டேன்றீங்க. எல்லா வீடியோ வேணும், எல்லாம் வேணும். ஆனா இதுவும் படிக்கிறது இல்லை. என்ன பண்றோம்? Odds ranges between 0 to infinity, positive infinity. Correct? 0 to positive infinity, plus infinity. 0 to plus infinity. Which one? The odds ranges between. Okay. Supposing if I say the odds is 0, what is odds of, the odds is 0. What does it tells us? Odds is 0 means that event is impossible. There is no chance of an event occurring. Okay, the odds between 0 to 1, what is the odds between 0 and 1? If the odds are between 0 and 1, what does it tells us? If the odds are between 0 and 1, okay, let's say a person, see the odds of a person winning between, a person winning in an election, the odds for him are between 0 and 1. So what does it tells us? It tells us the probability is less than 50%. The closer the odds are to 0, which means less likely the event can happen. Okay, so that is what. And then let's say if somebody sells, right, the odds are equal to 1. What does it tells us? The odds are equal to 1 means the probability of an event occurring is 50%. என்னம்மா ஸ்டாட் ஸ்டூடெண்ட் எல்லாம் கிளாஸ்ல தூங்கிட்டீங்களா? Odds greater than 1. What is this odds? Okay, let me do one thing. If odds are odds of 0, what does it tells us? No chance of the event occurring. No chance of the event occurring. Number 2, the odds between 0 and 1. The odds between 0 and 1. What does it tells us? The event is, or it has a probability, right? The event is unlikely to, or the event is unlikely, or the event has the probability less than 50%. Am I correct? Yes, Anwar, you are correct. Anwar, Swami, you are correct. If I say odds equal to 1, what does it tells? Odds are equal to 1. Dhanraj, guest lecturer. Dhanraj, why don't you tell me what is odds equal to 1? When the odds are exactly 1. Odds are exactly 1. What does it say? The event is, the odds are equal to 1, right? Yes. So even in this case, the probability of occurring is the probability of occurring an event is 50%, correct? Less than 50%, odds are between 0 and 1. If somebody says the chances of winning, the odds of winning is between 0 and 1. The odds of winning is between 0 and 1 means, so the event has the probability less than 50%. The odds of winning is equivalent to 1 means the probability of winning is 50%. Okay, the probability of winning is 50. If it is greater than 1, that means probability is greater than 1. Probability is greater than 50%. Sorry, probability is greater than 50%. So the larger the odds value, the more likely the event can happen. Okay, if the odds are approaching infinity, see here, the odds ranges between 0 to plus infinity. Plus infinity, when the odds are closer to infinity, that means the event is almost certain to happen. It is going to happen for sure. If the odds are approaching infinity, odds are approaching, the odds are approaching infinity, that means close or infinity, see anything, the all odds values are closer to 0, that means the chance of happening is very less. Anything which is closer to plus infinity is it is going to happen for sure. You understood? So remember this very well. Okay. So next one is, for example, I'm going to give you some example, because you need to understand this one very clearly. This is the building blocks for understanding the logistic regression, the odds ratio. Okay, I'll give you some other examples, or some let's work on some other task. Okay, assignment. Okay, I'm going to say so for example, if the probability of winning is 6 out of 12, what are the odds of losing? What are the odds of losing? Tell me in terms of odds. If the probability of winning is 6 out of 12, what are the odds of losing? I'll give you the clue. The total probability is 12. Out of 12, there are 6 possibilities, right? 6 out of 12. Out of 12, 6 chances are that winning. Already winning solita. Apna losing na enna artham. What are the losing thing? 1 second. Sorry, there is some net issue. Okay, now it is fixed. Okay, the other students have net issue. They sent a message. So 6 out of 12, right? If the probability of winning an election is 6 out of 12, which means what is the probability of losing? The remaining 6, right? In the 12 on the outer 12, 6, 6. The probability of winning is 6, probability of losing is 6, right? So 6 out of 12 is winning, right? So that means 6 out of 12, and the losing is also 6 out of 12, right? Is it okay or not? Is it correct or not? It is correct. How many of you agree with me, or how many of you are able to understand this one? If the probability of winning is 6 out of 12, what are the odds of losing in artham? Total probability கீழ கொடுத்திருக்கான் denominatorல 12. Yeah. So 6 out of 12 chances that you are going to win. That means the remaining 6 out of 12. மீதி எத்தனை இருக்கு 12ல? 12ல 6 போச்சுன்னா எவ்வளவு 6 இல்லையா? The remaining 6 out of 12, that are the odds of losing. என்னப்பா எல்லாம் MSc statistics ன்றீங்க. Okay, next one is, okay, I'll give you another example. Okay, another problem. If the odds of winning if the odds of winning are 13:2, what now the question is, what is the probability of winning? Inga, I will give you one clue. The first one, just before the colon, right? So what this is your winning, this is your losing. Okay. Now understand the question. If the odds of winning are 13:12, and here the 13 is winning and 2 is losing. Okay. What is the probability of winning? Now you need to tell me in terms of probability. What is the answer here? Just give me a second here. I'm getting calls from office. We have some production migration. Please bear with me, okay? Type it in the chat window quickly. Yes, yes, very good, very good. Soumya, you are correct. The winning I've given you the winning. The probability of winning is 13 divided by 13 plus 12, 2, right? Winning plus losing. Total probability. So this is the one is nothing but your 13 out of 15. Okay, 15. So this one is somewhat closer to 0. Approximately, right? 0.8, 8667. Okay. This is for probability of winning. Ipo Salanga, what is the probability of losing? Probability of losing enna? See, total probability is 15. Ma purida illiyam ellame. Probability of 13 now. Probability is no, not probability of 13. Okay, at least paravala answer pannunga. Right? Good. So what is the probability of winning? The probability of winning na enna arthana? Number of favorable outcome divided by total possible outcome. Total possible outcome 15. 13 plus 2. Winning, losing, are the total possibility, right? The winning was the 13 numerator. This is the favorable outcome. This is the probability of winning. What is the probability of losing? Analytical thinking suttama ille. Don't get me wrong. Okay? Suttama ille. IQ suttama ille. Okay, let me just check. Here, the probability of losing one day 2 divided by 15, right? 2 divided by 15 எவ்வளவு வரும்? Yes, you are correct. ஜீவானந்தம் அதர்ஸ் ஏதோ அவங்க அதர்ஸ் வந்து ஒரு குரூப்பா ஜாயின் பண்றாங்க ஆஃபீஸ்ல இருந்து. அவங்க தே ஆர் ஒர்க்கிங் ஆன் வீக்கெண்ட்ஸ் ஆல்சோ. அவங்க ஏதோ சம் ப்ராப்ளம் ஜாயின் பண்ணல. ஓகே, 0.133, right? Yes, you are correct. 133. That is what we are getting it here. You are correct. The புரிஞ்சுதா இப்போ ஜீவானந்தம், right? If the odds of winning are 13:2, no, the total possible outcomes are ரெண்டுத்துமே ஆட் பண்ணிக்கணும், ரைட்டா? அப்போ வின்னிங் கேட்டா 13 divided by 15, losing கேட்டா 2 divided by 15, அவ்வளவுதான். But if they ask you in terms of odds of losing, okay, அதுக்கு என்ன சொல்லுவோம்? I mentioned about 6 out of 12 probability of winning. Probability கொடுத்திருக்கிறோம். And now you need to tell what are the odds of losing. Probability odds க்கு என்ன ஃபார்முலா சொன்னோம்? Probability of success divided by probability of the failure, right? 1 minus probability of success. So odds of losing na enna artham? 1 minus probability of winning divided by probability of winning, right? So in the simple solana 6 out of 12 chances that winning and 6 in the odds of losing are 6 out of 12. In the 6 out of 12 என்ன அது என்ன வரும் இந்த 6 out of 12 என்ன அர்த்தம் 1 divided by 6 வருமா 1 divided by 2, right? 1 divided by, we can say 1 by 2 more in 1 divided by 2, we can say 1 by 2, right? If you simplify this, you will get 1 by 2. So, and if I plug in this one into our formula, 1 minus 1 by 2, I'll explain you, don't worry. 1 by 2 is equivalent to 1 by 2 into 1 by 2 is equivalent to 1. Correct? So, இது என்னது my 1 minus here, 1 second, odds of losing, right? Odds of losing is okay. Odds of losing na என்ன அர்த்தம்? இப்போ odds of winning na என்ன அர்த்தம்? ஃபார்முலா என்னது? Odds of winning. 1 second. Odds of winning. இது நான் எழுதிடுறேன். Odds of winning. விக்னா winning ஞாபகம் வச்சுக்கோங்க. Odds of winning na என்ன அர்த்தம்? So இங்க 1 by 2 இல்லையா? 1 by 2 divided by winning, right? Odds of losing na என்ன அர்த்தம்? Odds of or the probability of losing வந்து 1 by 2 divided by odds of winning, right? Odds of winning. அதாவது if they give the probability and if they ask you, tell me the odds of losing or winning, அப்படின்னா எப்படி பார்க்கறது? And if they give the odds and then if they give you the probability, if they ask you the probability, okay? But this given odds and what is the probability of winning, what is the probability of losing, அப்படின்னா இந்த மாதிரி இது வந்து கிளியரா இருக்கு இல்லையா? ஸோ இந்த கேஸ்ல வந்து odds of losing எப்படி கண்டுபிடிக்கிறது? Odds of losing இதுல 6 out of 12, right? So இங்க வந்து பார்த்தா odds of losing is equivalent to 1 divided by the probability of losing, right? So 1 divided by 2. So இது பார்த்தீங்கன்னா 2 வந்துரும், right? இந்த 2 மேல போயிடுச்சுன்னா இந்த சாரி 2 மேல போயிடுச்சுன்னா 2 divided by 1 by 1 cancel ஆயிடும், 2 தான் வரும், right? So therefore the odds of losing are 2 here. The odds of losing are 2 here, okay? Odds of losing is 1 divided by probability of losing and odds of winning என்ன அர்த்தம்? 1 divided by 2. அங்க பார்த்தீங்கன்னா the odds of winning என்ன சொல்லணும் நம்ம? The odds of winning is the probability of winning divided by probability of losing, right? So probability of winning is ஏற்கனவே தெரியும் 6 by 12 is nothing but 1 by 2 divided by probability of losing, right? அதுதான் வந்து odds of winning. Odds of losing வந்து 1 divided by probability of losing. So 1 divided by 1 by 2 is nothing but your 2. The odds is 2. The odds are 2 here. In this case, we will explain you the probability here, right? And the next problem is for example, the third problem, okay? The odds of winning are 3:8. Okay, what is the probability of losing? The odds of winning are 3:8. What is the probability of losing? இதுக்கு எப்படி சொல்லுவீங்க? ஏற்கனவே சொல்லிட்டோம் இல்ல இத? Already you relate with this one, right? Let me see how many of you can answer this one. Third one. If the odds of winning are 13:2, அப்படின்னா இது win இது lose. If the odds of winning are 30:2, எல்லாமே கால்ல இருக்கீங்களா? ட்ரைனிங் அட்டெண்ட் பண்ணீங்களா? இல்ல வேற யார்ட்ட பேசிட்டு இருக்கீங்களா? இல்ல டிவி பார்த்துட்டு இருக்கீங்களா? What is the probability of losing? சீக்கிரம் கவுண்ட் பண்ணி சொல்லுங்க. தீபா ஒருத்தங்க கரெக்டா சொல்லிட்டாங்க. So 3 is winning and 8 is losing. The probability of losing is 8 divided by 11. 8 divided by 11 பண்ணா அது என்னவோ அதுதான் வந்து probability of losing, right? Probability of winning வந்து பாத்தியமா இருக்கீங்களா இல்லையா? So 3 divided by 11, that is what the probability of winning, right? Next வந்து the probability of losing is 6 out of 8. இந்த ஒரு எக்ஸாம்பிள் எடுத்துக்கலாம். The probability of winning is 6 out of 8. What are the odds of winning? என்னன்னா, if the probability of losing is 6 out of 8, what are the odds of winning? Total வந்து 8, right? Losing is out of 8 ல 6 chances are losing probability. அப்படின்னா என்ன அர்த்தம்? Remaining 2 divided by 8 are winning, right? Winning. 2 out of 8. So how much you'll get? 2 divided by 8. How much you'll get? Yes, Deepa, you are correct. Calculating. Okay. You do calculation and tell me. I'll give you time. Hmm. Two out of 8. Okay. 0.5. 0.5 வந்து probability நம்ம oddsல சொல்லணும். Okay. Here okay, I'll just remove this one. Odds of winning, I'll just write it here. Odds of winning. Diploma. Odds of winning. The question is odds of winning, right? The odds of winning is equivalent to 1 divided by, we can say the probability of winning, right? Probability of winning. 1 divided by 3 by 4 இது probability of winning என்ன வரும் இங்க? So இங்க பாத்தீங்கன்னா probability of losing is 6 out of 8. அப்போ winning வந்து 2 divided by 8. 2 divided by 8 எவ்வளோ வரும்? 2 divided by 8, 1 by 4, right? So இல்ல 3 by 4 வருமா இங்க? Okay, probability of winning வந்து 3 divided by 4. Okay, 3 divided by 4 அப்படின்னா 4 divided by 3 வரும். So the odds of winning are 4 out of 3, right? There is a 4 out of 3 chances that he can win. Can we say this way? Is this correct? Statistics students. Yes. Maybe you know in your college they would have used some other formula, right? Probability of seeing எல்லாத்துக்குமே ஒண்ணுதான். Probability of success divided by probability of failure. Odds of winning na enna? The probability of winning divided by 3 by 4. So இந்த 6 by 8 நம்ம சால்வ் பண்ணா என்னமா வரும்? 6 by 8 சால்வ் பண்ணா 3 by 4 இது வந்து என்ன வரும்? 3 by 4. Okay. Deepa, so you know this is the one you will get. So the odds of winning is 1 divided by probability of you know losing. Sorry, probability of losing this one. Okay, that's why you got confused, right? Losing, probability of losing. So 1 divided by probability of losing is either if you solve this one, you'll get 3 by 4, right? So 4 by 3. Okay, and what is the odds now? 1.33. 1.33. So odds of winning வந்து sorry, okay, odds of winning வந்து 1 divided by probability of losing. Okay, probability of losing. So odds of winning other odds of winning, correct? All right, okay. So here we can say 4 out of 3 chances, right? 4 out of 3. Okay, இது என்ன பண்ணணும்? This is odds of winning. This one you need to multiply with the odds of losing 3/4, right? So if this one and this one will get, the இங்க வந்து 1 வந்துரும். Odds is 1. The odds of winning when the probability of losing is 6 out of 8 or 1. The odds of winning when the probability of losing is, இங்க கொடுக்கும்போது probabilityல கொடுத்துக்கிறோம். The probability of losing 6 out of 8, which is nothing but 3 out of 4 or 1. This means என்னது? The odds of winning are 1 to 1, which is the same as 1:1 odds ratio, or a 50% probability of winning. 1:1, right? So there is a 50% chance of probability of winning. Okay, probability of winning. You can say that way also. Okay, the odds of winning when the probability of losing is out of 8 is 1. Got it? So probably I will give you some more assignments. You can work on it so that you'll be able to understand clearly. Okay, next one is we will proceed with understanding what exactly logistic regression is all about. Okay, binary logistic regression. That is, using logistic regression, we can solve the classification problem. Like logistic regression, there are different types of algorithms are available to solve the classification problem. As I told you, to solve the regression problem, lot of algorithms are available. You can use neural network, you can use support vector machine, you can use the XGBoost algorithm. Okay, likewise, you can use different types of algorithm to regression problems. Similarly, you can use the same algorithms to solve the classification problem. Usually, to understand the classification problem, we start with the logistic regression. What is logistic regression? See, many business problems and decisions that deal with understanding or estimating the probability associated with certain events or behaviors, even our day-to-day life, right? So certain decisions, right, that deals with estimating the probability. See, in our practical life, we use percentage. What are the percentage of chances that I'm going to clear the interview? Now, this client interview, what are the chances that I'm going to? So we use everything in terms to predict the uncertainty. We use percentage, but when it comes to statistics, usually the statistician, they use probability. Okay, what is the probability? As I told you, the probability values are ranging between 0 and 1. What any value which is closer to 0, that means unlikely to happen. Any value closer to 1, that means the chances are high that that event can happen. Okay, supposing in the case of bank, the bank decided to offer the loan to the customer, right? So in that case, before offering the loan, the common, in general, there are 2 questions will pop up to your mind. What are the questions? Before giving the loan to someone, the 2 questions you need to ask, right? How risky is the borrower? How risky is the borrower? Given the borrower's risk, can I approve the loan? Okay, given the borrower's risk, can I approve the loan? How risky is the borrower in artham? We are going to quantify it with some probability. Say someone by the name of Raja. What is the how risky the customer Raja if I offer the loan? The probability is somewhat closer to 0.3 or something like that. That means less risky is not that risky guy. Okay, that means the chances of defaulting are less. Okay, so with this risk, we have quantified the risk in terms of probability, right? So with this given risk of probability 0.3, we can close our eyes and approve the loan. Okay, and so for example, this is a given data set. Let's say you have customers are applied for loan with your bank. The customer name and his age and gender, and you have his income and profitable. This is the For example, whether if the customer is profitable in the sense, we can approve the loan to him. You just think that way, okay? Customer name is something like Chris, John, and Anwar, something like that. Okay, age is, he is 48 and he is 59, and Anwar is just 25 years. So all are male. What are their income? This guy's income is, 100K. This guy's income is 500K. Okay, this guy's income is, 2,50,000, something like that. Okay, so based on the past historical data. Okay, now I have to train my model. That means I need to have the historical data, which should comprise the input features, and then the labeled output feature. So here I'm using a different term, labeled output. When it comes to classification problem, instead of saying dependent variable, we say labeled output feature. Okay, profitable. Here, let's say they have given you, this guy is profitable, this guy is non-profitable. Okay, so this is the class label. Yes, N. So binary classification here, right? The profitable is a classification, what is it? Categorical column. This column has only two classes, yes or no. Okay. So these two customers are profitable customer. These two, this customer is Anwar is non-profitable customer. So you train your model with the combination of these two input features and label output features. Okay. And then you apply the train model on the unseen data. For example, instead of Chris, you have someone by the name of, his name is X and his name is Y, Z. Okay. Different customers. Okay. And then here, so these three customers, they applied for a loan recently. Okay. The previous one with yes, yes, no, right? They applied in the past. In the past, these two guys did not default and one guy defaulted. With that, you train the model. Next, you take a new customer, this customer. Now your manager is telling, hey, you are a data scientist. Can you tell me X, Y, Z? These three guys, they applied for the loan. Can you tell me whether they are profitable customer or not? So then what is you apply the train model on this test data or unseen data. And what your model has to give here, it has to say either yes or no, right? Your model has to say yes. It has to give it has to assign the class label as yes or no. This is the predicted class label. It has to assign the predicted class label. If you give the loan to X, the chances are profitable is yes, yes. And no means don't give him. So along with this profitable, if I give the probability, okay, the customer is, you are saying that this customer is non-profitable. What is the probability that is non-profitable? Okay, non-profitable. So these guys are somewhat, 0.89, 0.92. That means, there is a higher chances these guys are profitable. This guy is non-profitable. But if you look at the profitability, it shows 8.87. Okay, 0.87. Okay, that means, this guy's probability is very high. In 87, it is not 0.5 or 0.321. But this guy is risky guy. Okay, there is but still, when it comes to profitability, there is a 0.87% probability that this guy can, this guy is also profitable, right? Profitable. So your model assign the predicted class level yes, yes, no to make it categorical. In addition to the predicted class level, the predicted probability also, we can assign it. That is what I'm trying to say. See, if somebody is good, listeners, yes, yes means good, right? This guy is good. What is the probability this guy is good? 0.89, 0.92. Okay, which is very closer to 1. Anything closer to 1, in this, as per this example, they are good guys. But 0.87 this guy got, but unfortunately this guy is not above or 0.89 or above. Okay, so just because this guy is 0.87, it should not be considered as he's a very bad guy, right? So with the help of the probability, we can decide whether this guy is profitable. So by looking at this, we can say, no, this guy is still profitable customer only. So along with the predicted class level, இத மனசுல திருப்பி சொல்லிக்கங்க. Along with the predicted class level, it assigns the predicted probability also. With the help of the probability, you can take a call. Okay, we can decide, right? Got it? So this is, these are the things we do it with the help of the logistic regression model. We can predict the class label, target class level. Along with that, we can, in addition to that, we can assign the probability also, right? We can assign the probability also. Okay, so you can use the logistic regression when the target variable, the dependent variable is categorical. In this case, the profitable is a categorical variable. Okay, yes or yes, no. Okay, so the logistic regression is to help or estimate the probability that event will occur as a function of other variables. We can say that way also, right? The logistic regression, this algorithm, we can use it to estimate the probability. What is the probability that, the person can be a profitable customer or non-profitable customer? We can do it. Instead of predicting a predictive model, Y, like in the case of linear regression model, right? Here, we are going to predict the log odds. That is the difference between linear regression and logistic regression. So here, we are going to predict, in the case of logistic regression, the logistic regression model predicts the log odds. Which I'm going to call as a Y. In this case, it gives me the odds, not the estimated housing price and all, right? It will not give you the estimated numerical value. Instead, it gives me the odds. Okay, what are the odds that log odds? What are the log odds that the given person is going to default if I approve the loan? Okay, so in this case, what happens? The formula for the logistic regression is natural log of natural log of what is odds? Probability of success, the probability of success divided by probability of failure, right? So I just say success is Y equal to 1, Y equal to 1. So what we are interested in predicting, we want to predict the probability of success. According to us, the probability of success is profitable customer. Okay, so P probability of Y equal to 1. 1 is success. And if I subtract the probability of success from the 1, that gives me the odds. So I'm going to take the natural log on the odds. That is what we are going to get once you fit the linear regression. Rest of them are same. B0 plus B1 x1 plus beta 2 x2 and all. Okay, plus etc. So beta naught is your intercept, and the beta 1, beta 2 are your slope. The right side is somewhat similar to your linear regression model. The left side is unlike linear regression model, we are not predicting the value of Y directly. Instead, we are finding out the log odds. Right? We are going to estimate the log odds. What are the odds that the given customer is going to default if I approve the loan? Okay, so that is what this one tells. Remember this equation. So, since we are taking the natural log on the odds, we call it a logit. They use the short term called logit. Okay, what is the logistic? What is the logit? We are going to predict the logit. What is the log odds ratio that a given person is going to default, right? That is what it tells us. So next question is, okay, why do I need to use logistic regression to predict the target class level, either yes or no, or the probability values? See, using logistic regression, you can predict the class level, and also you can predict the probability also. Okay, remember this. Now the question is, okay, why can't I use the linear regression model, and why should I use logistic regression to predict the class level? Okay, class level. Okay, linear regression. First of all, what is the difference between linear regression versus logistic? Linear regression, we can use it when the response variable is continuous. Like if I want to predict the housing price or weight or height. So in that kind of situation, linear regression is helpful. Whereas logistic regression, we can use it when the response variable is categorical in nature. For example, yes or no. Yes means the customer is profitable customer in this case. Okay, no means the customer is not profitable customer. Okay, yes or no, or true or false. And whereas in the case of linear regression, the coefficient like a beta naught, beta 1, right? Sorry, the slope variable. How do we interpret? We interpret the coefficient for the independent variables are quite straightforward, right? Holding all the other variables constants. With the 1 unit increase in the variable, the dependent variable is expected to increase so and so bar, right? So by so and so. That is what we can. But whereas in the case of logistic regression, depends on the family and link. So it depends on the family. So in the logistic regression, you have something like a binomial logistic regression, Poisson logistic regression, and all is available. Okay, based on which we are going to predict. But in the case of logistic regression, we interpret the slope as something like if a 1 unit increase in the age, there is a log odds that the person is going to default. There is a percentage of this one. The 1 unit increase in age leads to, there is a 0.8 log odds increase in defaulting. That is how we are going to interpret. The interpretation of the slope is different between linear and logistic regression. The linear regression model uses something called OLS method, ordinary least squares method, whereas the logistic regression uses maximum likelihood estimation. The logistic regression algorithm uses something called maximum likelihood estimation. I have discussed this one in my previous batch video. You can watch that video. There, the PowerPoint, I used it very clearly. Okay. And maximum likelihood estimation to estimate the parameter. To estimate the parameters, here we use MLE, whereas in the case of linear regression model, there is something called OLS method is used to estimate the coefficient values, beta naught, beta 1, beta 2, and all. In the case of linear regression model, this is for linear regression. Whereas in the case of logistic regression, it uses some maximum likelihood estimation to estimate the parameters. What do you mean by parameters? The coefficient is also called as your parameters. Okay, now the question is maximum likelihood estimation. What exactly maximum likelihood estimation? So what it does is it maximizing the likelihood function to determine whether the parameters that are most likely to produce the observed data. The slope and the slope values are determined. The values for the slopes are determined in such a way, right? It most likely produce the observed data. Okay, for example, profitable, we say 1. Instead of say yn, we use 1 in practice. Okay, we don't say yn and all. Instead, 1 means y, true. Okay, 0 means false. Okay, so this is my actual value, the predicted value for the, what is my model predicted for this customer age and gender and with his income. What is my model's predicted class level? If this is also somewhat close to 1, that means it's correctly predicted. And if it is something like 0.8 something like that, it is somewhat close. And 0 means 0, right? That means this customer is most likely to default, don't give the loan to him. So it will determine the value for the slope in such a way, it most likely to put the observed somewhat, this one, the predicted and actual is somewhat close by. Okay, that is how it will try to predict the maximum likelihood estimation. Okay. Okay, Deepa says I'm overwhelmed. Can we continue the next session? Yeah, Deepa, so many topics are there. We need to cover.